Welcome to Hence the Future podcast. I'm Mattimore, and today we're going to explore the many worlds interpretation of quantum mechanics. We're also going to explore the more mainstream Copenhagen interpretation, as well as some other theories like the simulation hypothesis, quantum field theory, hidden variable theory, and Hilbert Space. Let's get into it. The inspiration for this episode is a quote from quantum physicist Sean Carroll, where he says, "The answer to the question of whether an electron is a particle or a wave is that it is a wave, but when we look at it, it looks like a particle." There is so much information packed into that quote, and the implications are vast. So let's unpack it. Science and scientists have been trying to figure out what stuff the universe is made of since the time of the ancient Greeks. The word atom comes from atomos, meaning that which cannot be divided any further. And so scientists would cut reality into smaller and smaller pieces and use more and more powerful microscopes to see what's going on at the micro level. But as our microscopes got better and better, and as we're able to observe even more fundamental particles than atoms, particles like photons and electrons, something deeply hidden emerges. We notice that these particles behave as a wave in aggregate, but when we look at them individually, they look like particles to our eyes. This phenomenon is demonstrated in the infamous double slit experiment, which if you haven't seen, it's definitely worth watching a YouTube video specifically on that experiment, but I'll describe it here briefly. Imagine you're sitting on your porch on a sunny day, and you're wondering to yourself, what is this light that's emanating from the sun? Intuitively, it seems like it's a wave of warm energy that's being emitted from the sun rather than individual packets of photons. But maybe it is these individual packets of photons rather than a wave. So if you want to figure this out, you could set up an experiment like the double slit experiment. So imagine you set up this experiment where you shine light through two narrow slits, and you want to see, will the pattern that emerges beyond the slits be a wave-like pattern, or will it be a pattern for discrete particles where there will just be a lot of markings specifically where the slits are, and there wouldn't be any wave-like pattern? What we see when we do this experiment is there is a wave pattern. The light that shines through the slits behaves as a wave would behave. But when we look at the individual photons going through the slits, they look like individual particles to our eyes. Now, this is what scientists mean when they talk about wave-particle duality, because reality appears to be made up of particles when we look really closely at them, but it's clear that the overall pattern is that of a wave. And when we're making predictions about where this electron or this photon is going to end up, it's far more accurate for us to use the wave function represented in the Schrödinger equation to calculate where that's going to end up in a probabilistic way. Now, no one can argue how useful this wave function is and how useful the Schrödinger equation is. It is currently our best way for calculating the state of reality. And anytime you're using technology that relies on electrons, so electricity, or photons, you're dealing with the Schrödinger equation and with these quantum states. So if you're using a cell phone, a computer, a television, you are relying on the Schrödinger equation for your device to function properly. So no one can argue that the Schrödinger equation is not the most accurate equation for reality that we have so far. The question that scientists do argue about is, what does the wave function really represent? Is the wave function just a wave of possibilities, and we only find ourselves in one version of actual reality? Therefore, the wave function collapses into just one reality when we take a measurement? If so, then you would be a proponent of the Copenhagen interpretation. Or do you believe that the wave function actually represents reality? Meaning there's more than one place where the electron ends up. There are multiple worlds where we could find ourselves. We just happen to find ourselves only in this one. If so, then you would be a proponent of the many worlds interpretation of quantum mechanics. Now, I have my own thoughts, but I want to give arguments on both sides so you guys can come up with what you believe to be the most accurate interpretation. Let's talk about some of the concerns with the mainstream Copenhagen interpretation. One main criticism is that it's called the shut up and calculate interpretation. meaning this is what quantum physicists are taught in school, and they're taught, hey, this is the equation you need to use in order to make these accurate predictions, and really science is all just about making predictions. We're not here to philosophize and talk about what it all means. Another criticism of the Copenhagen interpretation is what's known as the measurement problem, which is what's so special about this act of measurement that results in the wave function collapsing into just one reality, whereas all the other times it's behaving as a wave with multiple possible realities. So what's so special about this act of measurement? Does it have to be a conscious human doing the measurement? What if I put a video camera there? Do I have to look at the video footage? What if you have not a human, but a dog or a cat or an insect doing the measurement? So there's all these weird questions that come up when you put some special significance to the act of measurement itself that don't really come up with the many worlds theory, because with many worlds, these are all possible worlds, so there's nothing special that collapses the wave function into this one. We just happen to be living in this one version of reality. Now let's talk about some of the criticisms for the many worlds interpretation, also known as the Everett interpretation. The main criticism is, okay, if there's all these other worlds out there and the wave function really does represent reality, meaning there is this wave of reality that's all in existence, we just happen to be on this one. Why are we on this one path of reality? Where are all these other worlds? Why aren't I experiencing this cloud of possibilities? And instead, why am I living a very classical existence where I'm only in this one version of reality? Now, my answer to that is that if you're into meditation, and if you're imaginative, and if you're a dreamer, and if you have strong intuitions, you can tap into the wave function of possibilities. And I would say that intuitively, it very much feels like we have free will, that we are steering the ship of our own reality with the decisions and the choices that we make. And even if we're all entangled as one giant universal wave function, which is what the wave function represents, there's only one universal wave function that represents everything in the universe, then it's true that we're all entangled with one another. We may also be entangled with other possible realities. So it's almost like when you make decisions in this reality, it can have ripple effects in other realities. And the mystics have been talking about this for so long, about how the oneness of reality and the nature of the universe as being either the void, which is nothingness, or oneness, which is everything interconnected. So I think it is a mistake to say that we view reality as only being this one possible deterministic future, past, and present. I think it's more accurate when we look deeply within our own conscious experiences to realize that it does feel like we have this wave of potentialities. When you look at the bands of wavelengths that we can perceive through our eyes, and the bands of wavelengths that we can perceive through our ears and through our smell and all of our senses, it's such a narrow set of wavelengths. So if reality is all of these different vibrations, we're only able to perceive a small sliver of that. And so we're not seeing the whole picture. We're only focusing our attention on a narrow set of what is truly real. So I think it would be a mistake to take this narrow set of what we perceive as being the only reality that exists. So from my point of view, the Copenhagen interpretation is trying to fit all of the laws of the universe into our little narrow ability to perceive. Whereas it seems much more likely to me that actual reality is far broader than what we're able to perceive with our limited senses. And therefore, that's why we aren't experiencing all these other worlds. If we did have far greater ability to perceive, and if we weren't limited by our three-dimensional reality, then we would be able to tap into these other worlds. And there are even theories that one day with technology, it might be possible to have what's called an Everett phone, where you could actually talk to some of these other forking paths in reality. Let's do some rapid-fire questions. The first one is, how does the simulation hypothesis fit in? A lot of people like Elon Musk and Max Tegmark and others have been proposing that it may be that we are living in a simulation. Now, where would that fit into the observations of quantum mechanics? Think of a video game, whether it's Zelda or Animal Crossing or Fortnite or whatever your favorite video game is. When you're walking down a particular path, reality is rendered as you go along. So if you're walking to the right, you'll see trees render in real time as you walk along the path in the video game. Now, this is actually pretty in line with what we see in quantum mechanics, where there's all these wave of possible directions you could go, but when you go down a certain path, that's the reality that's rendered for you. And there's not really anything going on in the other parts of the video game when you're not playing in those parts of the video game. So this would be more in line with the Copenhagen interpretation, where the only real reality is the part of reality that you're playing in the video game, and it's really rendered on demand, almost as a way of saving energy and time and having an efficient computer system. Now, I actually think that the simulation hypothesis is too simplistic, and it might be because we are in this time in history where we're so focused on computers and software that I think that's what's leading a lot of people to compare reality to computer systems. I don't think that's the best way of describing reality, but it is an interesting thought experiment, so I think it's useful to view reality through that lens. There's another theory called hidden variable theory, which basically says that there is some hidden variable that, if we knew it, it would allow us to observe the quantum wave function more directly. Basically, this states that we don't have the final equation yet. There is some equation that would allow us to understand reality and all of its potential branches. This is actually what Einstein himself believed, and it's quite possible. We can't know if the Schrödinger equation is the be-all, end-all of describing reality. It's probably not. But I feel like this hidden variable theory is a little bit of a cop-out. There hasn't been much progress made along those lines, but it's something we should definitely keep in mind. The last rapid-fire concept I want to talk about is Hilbert Space. Hilbert Space is the space of all potential realities that we could be in. So imagine reality as this ocean of possibilities splashing in all directions, and we just happen to be splashing in this one particular direction on this arrow of time in a three-dimensional world, and that's what we have access to. But if we were a higher dimensional being that had access to all of the dimensions and all of the wavelengths of light and sound and smell and everything else, then we would be able to surf the wave function in all different directions, not just the direction that we find ourselves in now. So I love to think about Hilbert Space as just being this grand potential of all of these different directions where you had made different choices in your life, where different events had happened, they'd unfolded in a different way. And to me, this seems like something that almost certainly exists. There is so much beyond what we can perceive, and there is some stuff that we can perceive with our instruments. Like, we know there's UV lights and X-ray lights and all these things that we can't see with our naked eye. Lord knows what's beyond the reach of our instruments. So to me, Hilbert Space is a really useful concept, and it's very humbling to realize that we're only experiencing this small sliver of the potential of what's out there. So rather than thinking of reality as these solid objects that are moving through empty space in a Newtonian sense, instead think of reality as all of these different fields. Everything is a field. There's an electromagnetic field, there's a field of light, there's a field of sound, there's a field of gravity, there's a field of the strong and the weak nuclear forces. Even particles and objects are really fields of energy. Like, a solid object is a field that has a lot of energy, so it's really hard to break that entanglement apart and put things in between this solid wood table. Whereas the same particles, when they're more spread out and they're less energetic, you would be able to put your hand through. So quantum field theory is really a way of seeing reality as all of these different fields that are interacting with one another, and there is no empty space. There's just fields in these different states. And what's really going on is that we are navigating through these fields, and at the same time, our brain is coming up with our own picture of what reality is based on the mechanisms in our brain, based on our senses, and based on the nature of consciousness itself. The other cool thing about quantum field theory is that you don't even need physical space to describe reality. Instead, you talk about how entangled something is with something else. So if you're really closely entangled with something, we would call that being closer to that thing. Whereas if you're not that entangled with something, we would call that being far away from something else. Now let's get into the future scenarios. Let's talk about the worst case scenario.
Worst case scenario.
In my mind, the worst case scenario as it relates to quantum mechanics is that we teach our kids that it's too mysterious, you're never going to figure it out, just memorize the formulas and just calculate and make predictions. I think that's a mistake. I think there's so much we can understand if we really try. And I think there's a lot we can understand if we really tap into our own intuitions and look deeply within ourselves in conjunction with the measurements we do in the external world. Let's talk about the best case scenario.
Best case scenario.
Best case scenario is that eventually we emerge as higher dimensional beings. And perhaps through technology, we're able to perceive a far greater slice of reality than we currently are able to. So right now we're trapped within the three-dimensional universe. Time only goes in one direction. We have a narrow band of reality that we can perceive. How awesome would it be if we were able to expand that band of what we're able to perceive, and we're able to unlock higher dimensions and really understand reality at a more fundamental nature. I've been watching this sci-fi show called The 100, and there's a character in that show called the Shepherd, who is basically a higher dimensional being that helps the main characters in the show get to the higher layers of technology and being able to travel from one planet to another. And he's really sort of guiding them along as they emerge and become more and more advanced beings. So I love that notion of some higher dimensional being helping us along. But even if there isn't a higher dimensional being helping us along, it does seem clear that the trend that we are on is that we are emerging and we are always doing better than we used to, and we're always understanding reality more deeply than our forebears. So it's super exciting to me to think that one day we may have answers to some of these questions, and for nothing else than the curiosity, but also for potentially unlocking greater degrees of joy and fulfillment than we have been able to so far. So I'm very hopeful, and I think there's so much we have the potential to understand in the near future. Let's talk about the most likely scenario.
Most likely scenario.
My most likely scenario is that the many worlds interpretation will be proven to be the correct interpretation. And I feel that the mystics already figured it out thousands of years ago. They figured out that when you're deep in meditation, you can tap into the unity throughout all of these layers of reality. And you can really sense the oneness of the nature of the universe. At the same time, you can sense that there are different ways the universe could go. If you make this decision, it may go that way. If you make another decision, it may go the other way. And I was watching this movie called Sliding Doors where they talk about this concept. And the main character, Gwyneth Paltrow, she has this scene where she just barely misses the door to the train. And then the movie splits in two. They show the path where she got on that train, and they show the path where she missed the train. And the path where she gets on the train is a much better life path for her. You know, she finds out her boyfriend is cheating on her, so then she meets a great new guy and she has a great new career. Whereas in the version where the doors close, she doesn't find out her boyfriend is cheating on her. So she's sort of taken for a fool and things go horribly at work and she gets fired. But the interesting thing to me about this movie example is that there are times where both paths collide, where something bad will happen to her in both. Or, you know, she may have a loved one that gets sick or dies, and that would be in both cases. So the universe and reality, I think, it forks into these different paths, and we can sort of choose our own little path within the cybernetic collective, but it will still merge back when there are big enough events that affect across different lines of reality. And that to me seems intuitively to be correct. We are all part of this one giant cybernetic collective, and we are all entangled with one another to some degree, but we have some choice in what things and what people we want to be most closely entangled with. So let's say you decide to, let's say you start a new relationship with someone, a romantic relationship, or you start a new friendship, or you start a new working relationship with some colleagues. You are essentially entangling yourself with them, and so you now have somewhat of a collective future, depending on how closely entangled you are. Whereas, let's say you break up with someone, or you stop being friends with someone, or you quit your job, you're decohering from those people and those events. So you're becoming less entangled with them, and they'll go off in one direction, and you'll go off in another, and yeah, they may still merge back later on. But to me, the many worlds interpretation is in line with intuitions. It's just that through our limited senses and through the way we're brought up with modern society, we are taught not to think of these potentialities, and we're taught to just view reality as this one definitive path, and you don't have any way of interacting with the other paths. And I think that's a mistake. I'd like to end today's episode with some final thoughts from Alan Watts, one of my favorite philosophers, who I think has the best interpretation of reality of anyone, whether you're a scientist, philosopher, any type of person. And he has this quote about wavicles, where he talks about maybe the question of whether reality is particles or waves is the wrong way to think about it. Maybe they're mutually dependent, and there's this coincidence of opposites that rely on one another for us to perceive reality. So here's the quote. "The physical world is basically vibration. Whether we think of this vibration in terms of waves or particles or perhaps wavicles, we never find the crest of a wave without a trough, or a particle without an interval or space between itself and others. In other words, there is no such thing as a half wave or a particle all by itself without any space around it. Every sound is actually sound silence. Only the ear does not register this consciously when the alternation is too rapid. It appears only in, say, the lowest audible notes of an organ. Light, too, is not pure light, but light darkness. There is no on without off, no up without down." I'll leave it with that for you to ponder. Thank you all for listening. This has been Quantum Mechanics and the Many Worlds Interpretation, and I'll see you next time.
The past, the present, and the future.
Our computer is picking up a strange signal.
The past, the present, and the future, baby.
What's the world coming to?
The past, the present, and the future. The past, the present, and the future, baby. The past, the present, and the future.
Will attempt to stimulate consciousness.
The past, the present, and the future, baby.
Behind the strange signal is an alien
The
intelligence.
past, the present, and the future. The past, the present, and the future, baby.
It's possible.
If you enjoy thinking about the future as much as we do, we invite you to join the HTF community. Simply go to hencethefuture.com, scroll to the bottom of the homepage, and add your email address next to the button that says Enter the Void. You can also follow us on Instagram and Twitter at hencethefuture. And, most importantly, we encourage you to please rate and review the show in Apple Podcasts if you haven't done so already. Our team reads and appreciates every single review. Thank you again for listening to today's episode and for staying curious, and we'll see you next week.